any further ado, I think I must invite Dr. Vanita Prasad to tell us more about resource efficiency in small and medium-scale industries. Over to you, Vanita. You're on mute at the moment.
Yeah. Should I start sharing the screen now?
Yes, please. Yes, you can start.
And I'm really thankful to Babji sir to inviting me for this particular insightful workshop. I am a startup founder, and I'm working on to solve the water scarcity issue for last 30 years. And my focus is into working together with water and energy. And that's why I think Babji sir thought of calling me onto this. So as a startup, what I am trying to do is there is a lot of things happening in the academic sectors, and there is a lot of technologies available, but it is not available to the small scale industry. So what I am trying to do is to convince these people, because convincing industrial people is also a difficult task. So I am trying to do that at this particular time by developing some of the biotechnological interventions to treat their wastewater. This slide moving. Slide moving, sir. Hello, is slide moving?
Yeah, Vanita, you're currently on current challenges in environmental management.
Okay, yeah. So these are the main challenges which we are facing as society. Industry energy requirements is increasing day by day. There is a requirement of generating electricity since we are moving towards more of electric consuming societies. Then there are waste disposal. That is the major problem, that we are disposing waste. There is a lot of effluent treatment issues which are happening, which are there. And the cost of treating these effluents are going higher and higher because of laws which are enforced. So we need a very effective waste to energy system, because these, as sir has also mentioned, that it is all correlated. When we want to produce energy, we need water. When we want to use water, we need energy to pump it, to use it. So all of them are interconnected. And that's how, when we see whole of the scenario, there is a lot of global greenhouse gas emission happening because of our energy requirements, because of our water requirements. So what we can do? Apart from greenhouse gas emissions, which is because of anthropogenic, there is natural emissions which are happening, but that is very less as compared to our man-made methane emissions. So again, when we are talking about to the industries, what they are forcing is, because the industrial belt, wherever it is coming, there is a deforestation happening. There is a global warming happening, because when we are doing an urbanization or industrialization, these are the after effects which are coming. There is a water scarcity issue happening, because every industrial sector, every urbanization needs a lot of, there is a water need. And when we are consuming the water from a particular area, we are depleting even our groundwater sources. So apart from that, every resource is now depleting. So we have to save not only the water, but all other resources. So resource efficiency is very important. That is, for the industry, they have to very carefully choose the raw material and the energy sources by which they will be starting their industries. A lot of industries are coming up. And apart from the industry which are coming up, the SME or the small scale industry, which are already there, they can modify their raw material usage or energy resources usage. That is very important, very much important. at this point of time. They can use their waste or mineralization of the waste so that this is not disposed, or they should not create any emissions or an hazardous or a risk for the surrounding society or the water table which we have. So the responsible management of material and energy flow during their production is very, very important. And therein all as we are doing a lot of digital thing, we are helping them to responsibly monitor that and standardize them. So attention is there now on recycling and disposal phase of the product life cycle, whatever they are producing. So we are now coming into that phase, and we need to understand what is the life cycle. Why industry should consider this resource efficiency is because this can help them to reduce their cost of material, chemical, energy, their disposals, their emission, because of if they are using very judicially, then there will be a very less cost for compliance. They will not have much issues. So on long term, this is very much required by the industry, and they need to get associated with the consultants or okay. So consultants like us or the technology providers which help them to improve their process or their production process. So if we come to the resource efficiency, what are the main indicators by which they can see how they are effectively using their resources is first is that their material intensity per unit of service. Whatever they are doing, what is their material intensity? What is their carbon footprint? How much greenhouse gas emissions they are doing? How safer they are disposing their hazardous material? What is their integrated management systems? So that is required by the industry to understand on the basis of these indicators. And when we see all these together, we will see that water and energy goes hand in hand. If they want to use less water, means they will be using less energy for pumping less water as solvent when they are saving on water. And if they are using less energy, these are so interrelated that if they keep these two things in mind, keeping their raw materials and choice of chemicals very wisely, then they will be saving a lot of issues which will be coming for compliance. So that's why what happens in industry is they have an input and then there will be an output, and output will be in the form of the waste or the byproduct. I will call it as a byproduct. Whatever is not required has been discarded, and they have to see how they and some of the industries are using a lot of raw material in a very wrong proportion. So that is need to be monitored or audited so that they can use a right quantity of raw materials to create the product which they are creating. There should be a molar ratio which should be studied and given to them by using a digital interventions. But when they have produced something, there are some kind of waste which is generated, and they have to manage those waste also. So this is there because of industry, because of municipalities, there will be waste generated. Whatever activity a man will do, there will be a waste generated. So that needs to be handled. And as we know, fossil fuels are depleting, and we have to move to other energy sources, and energy security is one of the most important criteria for all the countries after this current scenario which has happened. And we all have this organic waste material resource as from industry as well as from municipality. Every country is having these resources, and especially if we see that this food waste is coming not only from the residential area, but every industry, when they are working, they have their canteens there, and they are the bulk generators of the food wastage which is happening there in their canteens. So that is a very important waste, I will say non-hazardous waste, which the industry is also generating. Apart from that, this food wastage is from food processing industries also. So as we understand, the circular economy is really the way forward if we have to grow sustainably. And based on these particular raw materials, what we call as bioeconomy will play a major role. It is interconnected when we talk about water, food, energy nexus. So we need to have a lot of potential products which can be formed from this particular thing. And anaerobic digestion is the main technology, or I will say a nature-based technology, which can be used to tackle most of the byproducts or the waste material which is generated. And we me as a scientist was focused on to understanding the metabolism, understanding the synergy in this particular ecosystem, and then working with these microbes, because this is a very complex system. Bioeconomy is taking upfront in India as well as internationally, but in India, the total, I will say, industrial products is coming up, and biofuels are totally a new sector which is venturing, and we are looking forward to create a bioeconomy from the industrial waste, which is organic in nature. Food industry, beverage industry, paper and pulp, there is a lot of industry which can be focused for specifically for generating energy. So we can see there are press mud, there are when we are processing coffee pulp, there are many kinds of when we are processing apple for apple juice, pineapple for pineapple juice, there are a lot of waste generated, and for that this closed loop system is very much required, because this provides a small scale industry a fuel which they need for their boilers at their site only. They are not dependent on for energy or onto any grid if they can use this particular thing. So understanding this particular complex process, then we really as scientists trying to understand this particular process, we see a lot of other useful products can be generated also. But at this point of time, what I am trying to do is I have done a lot of the products using these special isolates which we have, and we give a special tonics for these particular microbes, and we maintain the health of these microbes. That is what we are trying to do. If I wanted to, as I mentioned, as a scientist, I wanted to make this anaerobic technology a sustainable way, a system, a grid where we can produce hydrogen as well as methane using these particular things, which can give us energy security. It can be used in India or across the globe using our material, which is renewable, which is always there. We are growing in population. We are doing a lot of industrialization. We will be generating a lot of waste. So that was my focus, that I should work on some technology from where we get able to do resource recovery. And from some particular waste, we are trying to do a combination. We are trying to get some byproducts, if possible, doing treatability studies of the complex waste. That is what we are doing. But our first product is anaerobic granulated sludge. This is the product which we have generated. This is a mix of 650 different microbes. And you can see what we could able to do is these microbes we have understood, and now we have packaged it in a form of biomass and nutrients, and we supply it to the various industries. And by doing so, we are helping to achieve the SDGs goals 7, 13, 6, and 11. This is really required by the industry, and we are now able to help industry to achieve this particular thing. And now I am discussing some of the case studies which we have done. The issue with anaerobic digestion technology is maintaining these digesters is really a mammoth task, and a lot of industry are facing a regulatory compliance issue because of these reactors not performing well. So one such problem was there in a potato waste generating plant, and their digester was not working, and it was acidic, and they approached to us, and within the first month when we started working with them, we first stabilized their pH, and then we started giving our cultures, and they could able to generate gas, and they are converting it to electricity. And this has happened in 2019, and since then this plant is working. So I can say around 500 or more than it's 20 ton per day plant. So if this is not processed, this will be going to the landfill site, which we could able to save. And this is the same example where municipality, we have worked with the municipality where they have segregated municipality waste, and we have commissioned their plant. And that's where, because we have commissioned the plant, they thought that plant is working very fine. And in May, they will be having a lockdown, but the gas production was happening. There was no waste coming to the site, but gas production was happening. We could able to sustain the plant. And as soon as this happened, they stopped dosing Devi nutrients. They thought this is not required, this product is not required. And again, you can see the gas production went down. And immediately when we informed them, because we were monitoring it daily, at this point of time, we could not able to provide an app. Now we provide with our product an app to the customer so that they can give us all the data from where we can do a lot of studies to make this process more user friendly. This is the same other example where they have a running plant in an industry where they were managing their kitchen waste. This is in Delhi. So similarly, they have a problem, and now they are producing a gas which is more than the balloon size they have thought of, and now they are thinking of expanding it, and that's what is happening. So there is a lot of scope of getting a lot of energy from the for these SMEs or the small scale industry from their own resources which they have. So this is an example of effluent treatment plant that were from solid waste, where they were manufacturing potato starch. So when they are processing potato, they are generating a lot of wastewater, and from their wastewater plant, we could able to recommission this plant because they got a shutdown notice because they could not able to process their effluent. And coming to the dye sector, when we are trying to work with dye sector, first we have focused on to the sludge generated by them, and we could able to demonstrate that when their sludge, which they are sending it to hazardous landfill site, can be a source to have a biogas plant rather than disposing it in and creating another heap of waste material. So now they are coming up with this particular modification in their ETP. Apart from this, we have worked with Aditya Birla Group, where they have, because they are doing viscose fiber, they are doing an acidic thing. And with anaerobic other set of archaea, that is sulfate reducing bacteria, we are now trying to treat that hard effluent, converting it to sulfide, and then using that sulfide to precipitate out the heavy metal that is there in their effluent. So that study is going on and has been successfully implemented at 1 meter cube plant size. Now we are trying to do it in a bigger size, and then that technology will be implemented by Aditya Birla Group. And these are some of the recognitions which we have got. And I am really happy to say at this forum that we are successfully collaborating with Kenya Center for Scientific Research as well as from Vietnam now to take this particular technology or I will say these cultures to help them to get a water. Because when we treat water from any industry, food processing industry, with this particular technology, then that water can directly be used for agriculture purposes, because it is a liquid fertilizer, and that is what we are trying to see, because we are having an agriculture based economy. that is what we are trying to achieve. So I'm really looking forward to all the stakeholders which are there in this particular workshop to give suggestions to improve it further or to collaborate and take this technology to various levels. Aim and mission of REVY is to provide water for everyone.
But thank you very much, Vanita. Thank you. Thank you very much. That was a very nice presentation.